we really wanted to understand what inspired each of our recipients to choose the field of engineering. And so we really dug into their early childhood and their educational area to understand who were their role models or who was around them that actually provided encouragement, or in some cases did not provide encouragement and they stubbornly went along anyway. And I think that's the part of the story that really wasn't written into history at all, was how did these people even find this path?
Hello, I'm Troy Eller English, archivist for the Society of Women Engineers. Welcome to Diverse, a SWE podcast. At a recent SWE local session, only 3 people knew who Beatrice Hicks was when they were asked about her, despite Beatrice being a co-founder and the first president of SWE, and a woman engineer whose patented gas density switch earned her a spot in both the National Academy of Engineering and the National Inventors Hall of Fame. So that moment raises an important question. How many other groundbreaking women engineers are at risk of being forgotten? And how can we preserve their stories? In January, members of the SWE Late Career and Retiree Affinity Group published the book Women Engineering Legends 1952 to 1976, Society of Women Engineers Achievement Award Recipients. The book highlights the first 25 recipients of SWE's Achievement Award and the impact these women made in their fields. Joining me to discuss these stories and the effort to preserve them are Tietjen and Holly Teig, both longtime SWE leaders and members who were part of the team that brought these stories to life. Jill and Holly, welcome to Diverse.
Thank you so much for having us today.
We really appreciate being able to tell the stories.
Let's jump right into these stories. Beginning with, how did the Late Career and Retiree Affinity Group become interested in the SWE Achievement Award recipients and their lives and careers?
Well, Deborah Kimberling from the San Diego section was researching women for a project of the San Diego Engineering Council, whom she called Legends. And she noticed that there's not good information about women engineers online. Some of them were completely missing. Many of them that did have a bio, the bio was more about their firsts and the fact that they were women and not their technical accomplishments. And so she basically made it her mission just because that she was going to fix the web about women engineers. So that's the first part. I think I'll let Holly then continue.
Well, I think the other part of this background story is that when you really look at women being written into history, they don't get the same representation as men for their accomplishments. As Jill said, the biographies that are in Wiki are less than 20% of them are women. When you look at women who are honored through the Inventors Hall of Fame or Nobel Prizes, it's a very small percent of the total population. And you know, if you think about that, what message does that send to young girls and women who are thinking about alternative careers? It says, you know, you're not represented. And we wanted to change that profile as we go forward by telling these stories.
There's another interesting statistic that is related to this, and that is in a standard United States history high school textbook of 500 pages. When I started my mission of writing women into history in the early 2000s, women were represented on 7 pages out of the 500. Today, the statistic has improved, but let's not get excited. From 1.5%, it's increased 10 times to 10%, but women are 50% of the population, 50% of the accomplishments. And so it's incredibly important to tell women's stories and write women into history.
That is a shocking statistic, but at the same time, I'm not, I'm not as shocked as I wish I was. We'll say that. So at what point did you and other members of the SWE LCR Affinity group realize that you wanted to document these stories formally in a book?
It's really a serendipitous process, Troy. I am the series editor for the Springer Women in Engineering and Science series, and my job is to recruit, sometimes strong arm, sometimes pressure. I mean, whatever the right word is, individuals to serve as volume editors for the series. And I had been after Ceil Craig for a number of years. She had told me she wanted to write a book on women in robotics. At the conference, the SWE 24 in Chicago, I had a booth at the SWE boutique for Springer, and she came up and I said, well, when are you going to write this book? She said, I'm not going to write that book. But what she also said was, SWE's going to be 75 years old. And there's 75 SWE Achievement Award recipients. And maybe we should write a book about those 75 because they needed to be documented and put into history. And I happened to be rooming with Deborah Kimberling, and I said to her, Ceil and I had talked about this process, and we both looked at each other, and I actually said, 75 is too many. If we want to get it produced in 2025, which almost happened, instead it was early 2026, we can't do 75, but we can do 25. And so Deborah and Ceil and Holly and others took that idea to a dinner on Saturday night. And Holly, you need to take the story from here.
Yeah, I kind of came into it on Saturday night at We24. We were having a group dinner, and Ceil, I was sitting right next to Ceil, and she knows that I like to write. And she said, we were kind of tossing around this idea today. And I'm like, count me in. I'd love to be an editor. This is exactly the kind of stories that I think are important that we as women engineers tell about other women engineers. Because who better can represent all the aspects of their lives in a way that honors their technical achievements as well as their personal struggles and motivations for being in this industry. So it was literally 2 weeks later, we had our first meeting where we brainstormed the content and general idea for the book. We started breaking up the work to be done, how we were going to author, how we were going to check in. Of course, we brought Troy in right from the very beginning. What I really wanted to highlight, though, is we could not have done this without the treasure trove of information that we have in the SWE archives. It was absolutely paramount to our success to be able to access that information and have those records going back. So, kudos to our foremothers who thought enough to create an archives and keep all that information through all those office moves through many, many years of the headquarters. And now to have you, Troy, in your position where we can get at and easily find that information.
My pleasure. And as a side note, I'm involved with another women's organization that was celebrating their 50th anniversary, I believe it was. No, 75th anniversary. And they knew virtually nothing about their founders. They didn't even know their founding members' first names because in any records they did have, they were listed by Mrs. H.W. Smith, for instance.
That was the times.
Fact. Yeah. So they don't even know the founding members' first names. So the foresight of SWE's members to save their records was just remarkable. And they saved a lot.
And for that, we're thankful because not only have the archives been important for this project, but many other people use them. They have been used for multiple other books within the Springer Women in Engineering and Science series. And the information that is contained in them, as Holly already
It's
said,
priceless.
is it's critical. It can't be done without this information.
Yeah. And especially some of these women, some of these Achievement Award recipients, some of them are very well known, but a few of them are not known very well at all, and that there wasn't that much information available about them. If we dig into who these Achievement Award recipients were, a lot of them entered engineering in the 1930s through the 1950s. And what do we need to know about that time period when we talk about their achievements?
Well, this wasn't a time period that was, shall we say, particularly welcoming for women. None of the anti-discrimination laws were in effect yet. There were many engineering schools that didn't admit women. I mean, my institution, where I got my undergraduate engineering degree, didn't admit women until 1970. And I entered in the fall of 72. Many of them came in through alternative means into engineering, through physics or mathematics or chemistry. Almost every single one of them was the only, or one of the very, very few that you could probably count on the fingers of less than one hand. And they were so dedicated and so passionate about their work. And we didn't know them. I mean, yes, Holly and I knew some of them, and we're going to talk about it in a little bit, that the things that we uncovered about these women and their stories makes us have pretty much, out of the first 25 favorites.
The other thing that I would say is, they were really trailblazers and they knew it. They were very conscious of the fact that they were an only or a first, and that they were a role model. And we saw that they spent a lot of time mentoring younger talent, both male and female, to acclimate the workplace to accept women in these roles. So, they really served in a very visible way that the male scientists and engineers didn't have to deal with. And I think the other thing that's important to mention about this time period is, there was a lot of industries that were born in 1952 to 1976. Everything going on with the space program, with computers, with environmentalism, with integrated systems, with controls of systems. We kind of went from the mechanical industrial age to this now computer-based industrial age. And so the good news was, for the women who got into these sorts of industries, there was opportunities for them to create their own space and really demonstrate that there are fields of study that needed to be generated and created out of these new industries. I mean, there was no computers for the first women who started. They were on the slide rules. They were working on hand calculations out of textbooks. It was hard mathematical work.
And that leads me to something else. I also started college using a slide rule. And one of the things that we did as the 6 co-editors, authors of the book, is we put our technological experiences into a front piece and then a back piece in the book, so that we were saying about the experiences that we had as technology developed. I started with a slide rule. Calculators came in while I was in college. These weren't as big as the computers that Admiral Grace Murray Hopper worked with, but they were still huge computers. The capability of the computers that sent men, astronauts, to the moon were significantly less powerful than what we have in this today. And to understand that this is the age of human computers. And actually, at least one or more of our 25 Achievement Award recipients was, in fact, a human computer, like the women in Hidden Figures.
Another thing I'd like to add in is we really wanted to understand what inspired each of our recipients to choose the field of engineering. And so we really dug into their early childhood and their educational area to understand who were their role models or who was around them that actually provided encouragement, or in some cases did not provide encouragement and they stubbornly went along anyway. And I think that's the part of the story that really wasn't written into history at all, was how did these people even find this path? Did they have a father that was an engineer? Did they have an instrumental school teacher in chemistry that encouraged them? Were they the first female that was mentored in a graduate student environment by a professor? I mean, they all had different ways that they came into the field, but I think that for me was something I really wanted to know since they were such outliers in their field.
Yeah, so can we hear some of those stories? Could you share a couple of the recipients whose stories really surprised or inspired you when you were doing this research?
I'm going to start with Edith Clarke and understand that when I talk about Edith Clarke, and maybe we can find a picture of this, I always show a picture of an electric transmission tower. That's my business. And so she actually provided fundamental concepts and fundamental algorithms in the business of the electric utility industry. She studied engineering, then she got sick along the way. I mean, it's just a fascinating story. By the time she was getting her first job as the first female electrical engineer in the country, she was 39 years old. She had already gotten a bachelor's degree. She had worked as a human computer multiple years. She had supervised other women who were human computers. She was frustrated. The two biggies in the industry, General Electric and Westinghouse, wouldn't hire her because they didn't have positions for women engineers. She was the first female to get a master's degree in electrical engineering at MIT, and no one would hire her. So she continued to teach. She actually went overseas and taught. She came back. General Electric finally hired her. She was one of the first 3 female fellows of the IEEE. She has been inducted into the National Inventors Hall of Fame. She invented a graphical calculator. I actually have an example of a different graphical calculator. And what it means is that instead of putting the numbers into a computer, you actually have a graph, and this one moves. You can see that it moves. And then you set the different characteristics of the different features or factors that you need, and then you get your answer. And so she developed the first one that provided algorithms for the basis of computation for electric transmission lines. I mean, she wrote the textbook. She wrote the 2-volume textbook. She presented the first papers, the first woman to present papers to the IEEE. Then she retired, except that the University of Texas decided they needed her to be the first female professor of electrical engineering in the country at the University of Texas, where she mentored graduate students and really provided a significant legacy. And I knew some of that before because I've written extensively about Edith Clarke, but I didn't know all of it. Oh, and what was her motivation? This is an interesting story. She had played cards as a kid, a game named Whist, W-H-I-S-T, and she just loved the strategy and the thinking that went into Whist, and she was bored teaching. But she found out that she really wanted to be an engineer. She used her inheritance to go to college and became an engineer, which is what she wanted to do because she wanted something as challenging as the card game of Whist.
That's truly a great story, Jill.
I loved that story. Also, I hadn't realized that, I knew about her graphical calculator. I hadn't realized that she designed the turbine system at the Hoover Dam, which, is impressive.
That's really impressive. Holly, do you want to talk about another one of my 25 favorites?
Yes.
Alice Stoll, because I just love her.
So at the We Local conference, when I presented on this topic, Alice Stoll is the number one person that I wanted to profile. And I told the audience there, Alice would be my friend if she was alive today, because she just was such a trailblazer and had such a quirky personality that you just can't help but love her. So Alice has 4 degrees that she got: chemistry, physics, physiology, and biophysics. And she got hired by the government and was supposed to work in this lab that was not yet constructed. And, so as often happens, when you're a new employee, you're just sitting at the desk doing nothing. And she didn't like that. So she went to her boss and said, give me something to do, anything, I just can't pass 8 hours a day here. So he looked around his office and came up with this big stack of data on acceleration. And he said, why don't you see if you can do something with this? So she took it and she started organizing the data. She published papers about the test results that were shown in this data. And she realized in analyzing it, she had other questions. So rather than wait around for this lab to get constructed, she started a whole program around acceleration and G-forces and how they impacted the human physiology of pilots. So think about that. She's taking engineering data and starting to correlate it to how it impacts a human being. And she actually developed a mathematical curve to help predict what would happen to pilots as G-forces and acceleration continued. And this was used by all the military organizations to understand how to develop, the various planes and other equipment that they needed to have. But she didn't stop there, because this whole science of how things impact humans got her thinking at night. And so then she jumped into another program where she started looking at how the human body is impacted by heat, by thermal situations like in a fire. And again, this kind of came out of the pilot situation. If a pilot had to eject a plane, how many seconds did he have to get out of the plane before he was burned alive if it was shot down? So she started doing some calculations. They started running tests, and she was able to come up with a really good calculation tool that could be used to understand the human body's impact from flames. And this work went directly into developing different fabrics to use to protect the pilots. Because at that time, all they used was nylon, and when it caught fire, it would burn onto the skin. Okay, so very bad situation, ugly. So she went forward and was able to work with a variety of manufacturers to come up with fire-resistant fabrics through a whole series of lab tests that she did. And so if you think about that today, firefighter suits, hospital garments, space suits, fighter pilot suits, all of these things are safer today in protecting the human body because of the work that Alice Stoll did. And I love something that she said as a quote that we put in the book, that she entered the field of engineering through the back door because she really couldn't get directly into it, and really was a founder in the field of bioengineering because she loved the interdisciplinary activity of bringing together the science and the human part of it.
And Holly, there are 2 sets of curves. Both of those sets of curves that you referred to are actually Stoll curves. So one that impacts fighter pilots and astronauts. It's actually one of the bases of the calculations needed for the space program. And then the second set of Stoll curves. I mean, how many people have 2 sets of curves named after them?
Yeah, she was also honored with the National Inventors Hall of Fame and the Paul Burt Award for Aerospace Medical Association. So very impactful in protecting the human body in these situations we were putting them in.
We have one more referral back to Beatrice Hicks, whom you mentioned, Troy, at the beginning. Her gas density switch, and I say this often when I speak, I really don't like chemistry. So I didn't understand for a long time what a gas density switch or a sensor was, but it measures the artificial atmospheres. And when I was researching Beatrice Hicks for her nomination for the New Jersey Inventors Hall of Fame and the National Women's Hall of Fame, I learned that that's a sensor or a switch that monitors the artificial atmospheres that provide insulation around electronic equipment, including transformers in the electric utility industry. And I actually found the article that she had written for Power Magazine, which I still read, Power Magazine, on how this switch worked in monitoring SF6 for power transformers. An absolutely amazing woman who has been inducted into the National Inventors Hall of Fame and the National Women's Hall of Fame.
Yeah, that switch is used in so many different industries. It's just amazing how much impact that one invention had.
As a non-engineer and also someone who also did not like chemistry, I really appreciated the explanation in the book. I knew about her gas density switch, but even just that short explanation in the book, it really helped me to understand what it was, how it worked, and the wide range that it's used in. It was used in the Saturn V rockets. It was used in fire extinguishers. It was used all over the place, which is why we should all know who she is, especially SWE members.
You know, the last thing I would say about Beatrice Hicks is she also was ahead of her time in owning her own business. And she did it at a time when it was very difficult for women with the financial laws that were in place to even hold assets in their own name and to have their own business.
Can you explain why it's important for engineers today to know about these stories from the past? I have an innate interest in it, but not everyone does, but they should, right? So can you explain why it's important to know these stories?
Well, I would say, you know, it's important from a representation perspective and a role model perspective. We want our readers to understand that these were very successful engineers who just happened to be women. And that means other women can look up to them and say, you know, look at the perseverance that they showed and the commitment that they showed to getting their education, succeeding in their career, and doing something important for humanity. And I think that is one of the most important elements of what we wrote into this book is the inspirational side of seeing other people that look like you in those roles. They were really trailblazers, as Jill mentioned, and so many of them had firsts. Sheila Widnall was the first woman faculty member at MIT School of Engineering. That was 1964. She became the faculty chair in 1979 and eventually was named as the first woman secretary of the Air Force in 1993. So think about that, 1993. That was a long time after she already had embarked on her career that, you know, others in our upper government actually recognized what was, you know, possible to do. This group had so many key accomplishments: National Inventors Hall of Fame, National Academy of Engineering and Scientists, more than 70 patents among them across 25 women. So they made significant accomplishments.
And I also think that it's important for us to understand not to take for granted the opportunities that we have today, that people actually, I mean, I don't know that we could consider this fighting, but in some ways it was fighting for our rights and persevering for the rights. And I mean, Edith Clarke couldn't be hired because there wasn't an opening for a woman engineer. That wasn't really that long ago, and that the opportunities that we have today, we need to take advantage of when they present themselves. And then the opportunity to understand the important accomplishments that these women had that impact our ability to do everything. I mean, electricity underpins what we do. Clean water underpins what we do. The computer age underpins what we do. And their accomplishments were pivotal to the quality of life and standard of living that we have today.
They demonstrated so much perseverance and optimism in whatever came their way through their life. Marguerite Rogers is one of the recipients we profiled in the book. She was well educated and, was doing okay in her career. And then her husband had a heart attack young, and she was widowed. She had 5 children, and she found her way to a position at the China Lake Naval Station and has this huge litany of accomplishments in weapons systems built over a very long career at China Lake. And she was able to do that by, bringing in help for her children, with her mother helping her. But, she didn't stop what she was doing when all these life adversity things happened to her. She found a way to not only have a wonderful family, but a successful career in what she was doing. Another interesting example that I wanted to highlight was Esther Conwell. So Esther was very successful in working in a field related to transmission of light at Sylvania. And when she got pregnant and her son was due to be born, Sylvania didn't have any sort of maternity policies in place. So when she left to have her child, they fired her, only to hire her back when she was ready to come back, because they didn't have any mechanisms in place to deal with someone getting pregnant in their workplace and having a baby. Now, the downside at that point in time was her long-term company pension was impacted because of the firing and rehiring. So we really have come a long way in our workplace policies to enable what are just normal life events to happen and for people to be supported properly and, retain their job and their pension and, all of the things that come with your employment. But, these ladies were the trailblazers in all these situations that we as women know just are normal things.
Esther Conwell's story, I hadn't heard a lot of this before, and that made me mad. But another thing that made me mad is how she attended the American Physical Society conference early in her career, and she was very surprised to find that someone else was presenting her graduate thesis paper research at the conference, and she had no idea they were going to do it. And so at the conference, which she was just planning on attending, she demanded that they let her present her own research. I appreciated her strength in that moment, saying, no, that's my research. I will present it right now. And that was a story I had not heard before. And it floored me, and I was mad on her behalf.
And these women had steel backbones. They just had to, because of all of the things, the situations like what you're just talking about right now, Troy, that happened to them over and over, and they overcame adversity and persevered, as Holly has already said, over and over and over throughout their careers. And that's actually a pretty important lesson for us too.
So one little mention that I'll make straight from the SWE archives is there was a lot of newspaper clippings that you had scanned about their Achievement Award selection for some of our early recipients. And I always found it very interesting to read what the LA Times or the New York newspapers would write about the recipients, because they really struggled to write about their technical accomplishments. They always wanted to ask, well, who was taking care of your children? Who would go to the school when your child was sick? And they had all these, society norm kind of questions. Or they would ask, who's cooking dinner at your house? Instead of saying, congratulations on your award through SWE. They just didn't know how to handle a person having these sort of technical achievements that was female.
Those newspaper clippings, they're funny.
They're a hoot. Sometimes you're like, oh my gosh.
They are a hoot.
Well, and they reflect the time period in which they were written. And unfortunately, when Yvonne Brill died in 2013, it was the same thing that happened for these recipients in this time period, the 1952 to 1976. So 2013 revealed that things hadn't changed very much since they decided to lead with her beef stroganoff instead of her contribution to rocket science and satellite navigation.
that it was also another jaw-dropping moment when that article obituary was published.
And these are exactly the reasons we wanted to write our own stories about these recipients, because we want to tell their legacy the way it should be properly told and have their stories reflective of the situations that we also were familiar with in the workplace.
I have really enjoyed reading the book. I also appreciated that you included before each section of 5 recipients some historical context about what was going on in technology, what was going on in the country, what was going on in the world of women's rights. I really appreciated that to help put their stories and their experiences into context. So you've published a book about the first 25 Achievement Award recipients, and what's next?
Well, we've already launched into the next 25. So we have started the writing process for Achievement Award recipients from the years 1977 to 2001. Jill and I are editing this volume, and we have quite a few regular authors as well as a number of new guest authors that are trying their hand at writing. It is truly a privilege to tell these stories. And the stories are different in this group of 25 recipients. Time has moved along, and there's a lot of development in microelectronics, in computers, in space. And our recipients had different challenges. They're now talking about the glass ceiling. They're talking about, overt discrimination that they are not going to put up with. They're starting their own businesses. So their stories are different than what we saw in the first 25. And we also have several recipients who are still living. So we have some opportunity there to make sure that their stories are in line with, what they want their legacy to be. So we've gone ahead and already updated Wikipedia with our recipients from the first book from 1952 to 76. But we know that there's more work to be done of significant people within SWE that need to be profiled and available to history beyond even these Achievement Award recipients.
All right. So as we wrap up, do you want to share any closing thoughts on what you want the readers and listeners to take away from your project?
We want them to understand that these were amazing engineers, that the accomplishments that they have, yes, they were the first here and the first there and the first every place else, but they also made foundational contributions to a wide range of technology that's important for our lives today, and that we need to honor them and remember them and know their stories.
I think we want our readers to also know how inspirational their stories are. These women didn't let the world tell them what to do. They decided how their own destiny was going to be made. They decided for themselves what they wanted to achieve, how they wanted to achieve it, and how they wanted to live their lives. And I think that is a great inspirational message that anyone who's pursuing a career in engineering or the sciences would enjoy reading about.
Absolutely. Well, I want to thank you for sharing this information about your book project and about some of SWE's amazing first 25 Achievement Award recipients. I've learned a lot working with you on this and reading the book afterwards. So thank you to everyone who's worked on the project, because there's been quite a few. So thank you for getting compiling all of these stories from different sources and putting them in one book. So I know it's been a tremendous amount of work, but definitely worth it.
Well, we couldn't have done it without you, Troy, and your help with the archives information. So thank you for collaborating with us. I know we asked a lot in a very short period of time because start to finish, we were done writing in 9 months. So we leveraged your time and talents a lot as well. And it was a wonderful collaboration from our side.
And thank you, Troy, for the wonderful foreword that you wrote for the book. And I should also mention that Karen Hording, the executive director and CEO of SWE, also wrote a foreword for the book, and they are wonderful additions to the material in the book.
It was my pleasure, and it's a great book. I highly recommend it. So I am Troy Eller English, and from Jill and Holly and everyone else at SWE, thank you for listening.